This lesson introduces a topic called direct variation. Often in mathematics, there's two quantities that are related. One example would be the distance you live from school and the amount of time it takes you to get here. So presumably, the farther away you live, the longer it's going to take you. And there's a relationship between those two quantities, the distance and the time required. In some cases, the relationship between two quantities or two amounts is very specific, and when you double one quantity, the other one doubles. If you're twice as far from school, does it take you twice as long to get to school? Maybe that's something for you to think about. Similarly, if you triple one quantity, the other one triples. And it works the other way around as well. If you shrink one, if you cut one quantity in half, the other one is also cut in half. Whenever you have this specific special type of relationship, it's called direct variation. So in the example of distance from school and time it takes, in reality it's more complicated than that, but we could say that the distance you live varies directly with the time it takes to get to school, meaning if you double the distance, it's going to double the time. Okay. There's a few different ways of describing or understanding direct variation. Sometimes we talk about it using our words, and we would say x and y are directly proportional. You'll also hear people say x varies directly as y. And again, what that means is that they share that special type of relationship. You have these two amounts, x and y, and they're related. When you double one of them, the other one doubles. If you cut one in half, the other one cuts in half as well. We often represent this situation with an equation, y equals kx. X and y are the two quantities. K is going to be a number called the constant of variation. That should make more sense after I go through a couple of examples of direct variation. But for now, understand that every direct variation relationship can be represented with an equation of that form. Y and x will be variables, k will actually be a number. Okay, so here's some examples of quantities that vary directly. Number of feet, x, and number of inches, y. For example, if you have, let's see, 3 feet, oops, let's put the pen on. If you have 3 feet, you know that that's going to be 3 times 12, 36 inches. Okay, and if you double that, 6 feet, you're going to double the number of inches, 72 inches. And if you wanted to write the equation for this, you would say y, that's the number of feet. Well, I'm sorry, that's the number of inches. Y is the number of inches. So to find the number of inches, you take the number of feet, x, and you multiply it by 12. I hope I didn't confuse you there. So let me say that again. To get the number of inches, which we're calling y, you take the number of feet, x, and you multiply it by 12. So in this example, the constant of variation is 12, because you always have to multiply feet by 12 to get inches. Okay, another example. Let's see, it's here somewhere. Hours worked, x, and wages earned, y. Assuming you're paid some hourly rate, the number of hours you worked and the wages you earn are directly proportional. So say, for example, you're babysitting and you're earning $8 an hour. If you work 2 hours, you're going to make $16. If you triple that, 6 hours, you're going to triple the 16 and get $48. And similarly, if you split the 6 in half, 3 hours, you'd split the 48 in half, 24. Again, we can also represent this with an equation. The amount of money you earn, y, is based on the number of hours. What do you do to the number of hours? Well, I said you're getting $8 an hour. So in this case, the constant of variation is 8. Okay, I believe I have one more example here. I thought I did. Can I find it? There it is. Hours of flying and distance traveled. Now, assuming that the airplane is going at a constant speed, maybe 400 miles per hour, then if you travel, say, 1 hour, you're going to go 500 miles. And if you double that, 2 hours, well, now you're going to go 1,000 miles. And let's see, suppose you multiply the 2 hours by 4, 8 hours, quadrupling. Well, I multiplied 2 by 4, so 1,000 times 4 is 4,000. Okay, I'm realizing that I initially said 400 miles an hour, but in this example I obviously did 500 miles an hour. Sorry about that. So the equation for this one, y, the distance, is, well, you take the hours, x, and you multiply by 500. So in this case, the constant of variation is 500 miles because you're going 500 miles an hour. Okay, hope that makes sense. Your homework. There's a word problem here. Josephine earns $8.65 per hour. How much does she make for 6 hours of work, 10 hours of work, and 100 hours of work? I also want you to write an equation. Let x be the hours worked and y be the money earned or wages earned. Write the equation that goes with it, just like in the previous example, and then tell me the constant of variation. And then for number 2, if I tell you that x and y are directly proportional, and I give you the constant of variation 1.5, that should be enough information to fill out this chart. Here's the equation, y equals 1.5x. Generally, we're going to put the y first. Y equals the constant of variation times x. So use that equation, plug these x values in to figure out what y is. And then you might have to think a little on how to find the x value that produces these given y values. But I have confidence that you'll figure it out. Please have this ready for class tomorrow. Pause the video if you need to copy down the problems.